So, on Thursday of last week, when we were last together, we went through basic plotting points on a graph. So, the plotting points on a graph is the basics of where we're about to go as we lay the foundation for Algebra 1, which focuses on two things: relations and functions. So we're delving deeper into mathematical relationships. Delving deeper into a mathematical relationship. So a mathematical relationship is a mapping or pairing of input values with output values. Input values with output values. So you put something in, you get something back. You put money in a vending machine, you're getting back whatever it is you wanted to buy. When you're dealing with math, you plug something into a problem so that you can get a particular answer back. When we were plotting points, x comma y, you're plugging in something for x to get back something for y. So the x and the y have special names. So the input values are called the domain. And the output value is called the range. Domain normally goes with the x values, and the range goes with the y values. Of course, a real life example of all this is you working a job. If you've already worked a job before, then you already know how this works. The number of hours you work would be your x values. That's your input values. That's your domain. That's your domain. The relationship is your hourly salary. So you make $9 an hour, you make $9 for every hour that you work. The amount of money you earn, those are your y values, that's your output, that's your range. You put in hours of work to get back however much money you make. So, main thing to take away: input's your domain, output's your range. Any questions before we continue? Again, if you have questions, type them in the chat, come off mute and ask. But as always, closed mouths don't ever get there. If not, then let's keep going. So, there are 4 ways to represent a function. The first way we did last week, that's with ordered pairs. Writing it as an ordered pair. Ordered pairs, you can also put them in a table. So, those 4 points, there they are in the table. You can also put them in a graph by plotting the points. And you can also draw them in a map. You can also draw them in a map. So all of these are representations of a relationship. Different ways to represent a relationship. So let's take an example and model this relationship. Very similar to what you'll be doing in homework, mini quiz, your quiz on this weekend, etc. Alright, consider the relationship represented by the ordered pairs 3, 2, -1, 0, 2, -5, -2, 1, 0, 3. First, we're going to identify the domain and the range, and then we're going to draw these ordered pairs using a table, a graph, and a map. So the first thing we're going to do is identify the domain and identify the range. So, the domain is your x values. Domain is your x values. So that's 3, -1, 2, -2, and 0. So of course we need to put them in numerical order. So the smallest number was -2, then -1, then 0, then 2, then 3. If you put a parentheses around them, that's fine. I put the brace because that's normally how you'll see it in a math textbook. But if you put a parentheses around it, that's fine with me. Your range is your y values. Range is your y values. So you have 2, 0, -5, 1, 3. Once again, put them in numerical order. So -5, then 0, then 1, 2, 3. That's your domain, that's your range. Any questions so far? Alright, doesn't look like we have any, so let's keep going. So, next thing is a table. So we're going to take the ordered pairs, put them in a table. Take the ordered pairs, put them in a table. Actually, I'm going to draw right in the middle. So if we take the ordered pairs and put them in a table, 3 goes with 2 because they were paired off with each other. -1, 0, 2, -5, -2, 1, 0, 3. Here's my table. So this is your table if you had put everything in as is, as it was given to you. Most of the time, the numbers will be in order. Most of the time, they give you a table, the x values will be in order. So if you put the x values in order, that's -2, -1, 0, 2, 3. But the y value stays attached to whatever x value went with it. So, since 3 was attached to 2, 2 has to stay attached to 3. -1 was attached to 0, So it stays that way. 2 comma negative 5 has to stay that way. Negative 2 comma 1 has to stay that way. 0 comma 3 has to stay that way. So if you put them in order, the x values go in order, the y values will follow. Any questions before we continue? And if you have questions, type them in the chat or come off mute and ask. Don't stay silent if you know you have a question, because I can't help you otherwise. That, and I'm going to assume that you know what you're doing. All right, let's take for the graph. Graph, you just plot the points. So 3 comma 2, 1, 2, 3, up 2, negative 1 comma 0, 2 comma negative 5, negative 2 comma positive 1, and 0 comma 3. Again, you don't have to connect the dots. We'll do more of that next week, but you just need to plot the points. The last one is a map. So when you do a map, you draw 2 rectangles. One for the x values, one for the y values. So again, the x values go in the x rectangle. The y values go in the y rectangle. Now what makes a map different from a table is that you draw arrows to the number it is assigned to. That's the difference between a map and a table. Maps have arrows, tables don't. That's the only difference.
Question.
Yes.
So just like the table, if the x values are put in order, would it be the same?
Now, for a map, that's the other difference. For a map, if we put the x values in order, we also put the y values in order. That's the only difference for the map. So for a map, you put the x values in order, you gotta put the y values in order too. Right. So you'll draw arrows to the numbers that they go to. So the x values, if you put them in order, there you go. The y values are put in order. You still draw arrows to match everything up. 3 is forever paired to 2. So 3 goes to 2. Negative 1 goes to 0. 2 goes to negative 5. Negative 2 goes to 1. And 0 goes to 3. So they're still linked. Now they're just not across from each other. They're still linked to each other though. So, any questions before we take a 90-second break? Yeah, I appreciate a couple folks who've been asking questions. If you don't ask questions, then you can't complain if you don't know what you're doing. You can't get mad at somebody if you didn't ask a question about it and you know that you're stuck. But we pause part B. So now we've looked at what a basic relationship is, a basic mathematical relationship. So, like with most relationships, if they're a strong relationship, they're taken to the next level. So, in mathematics, there is something similar to a marriage in mathematics. In math, that marriage is called a function. A function is like a mathematical marriage in which each input has only one output. One input, one output. Just like a marriage. One input, one output. Meaning one x value cannot give you more than one y value. You're basically saying you can go to two different places at once, which can do that. Now, determining whether a relation is a function depends on how it was given to you. So, ordered pair, table, map, and graph, depending on how it's presented, will determine how you go about working it out. So let's start with ordered pair and a table. For an ordered pair, the x value only has one y value. In other words, the x value cannot repeat itself. The x value cannot repeat. So if you have an ordered pair and if you have a table, x cannot repeat. So let's look at an example that is true and an example that is false. So, true example. Here's our ordered pairs. We're looking at 1a. There's your x values. -2, -1, 2, and 3. None of them repeated. No x value repeated. So that makes it a function. That makes it a function. So let's look at 1b. 2, -1, 5, and 2. So, which of the x values repeated? Something repeated itself. 2 repeated itself. 2 repeated, so that means this is a fail. It is not a function. That's how you tell the difference.
As far as the y, as long as the x doesn't repeat, it's still called a function.
That's right. The y can do whatever it wants. The y value can do whatever it wants. It's the x value that can't repeat. X value that can't repeat. Any questions with an ordered pair? Tables do the same thing. Tables follow the same rule. So, for a table, -2, -1, 0, 1, 2. So again, there's no repeats. Remember, the y value can do whatever it wants. It's the x value that cannot repeat. No repeats, it's a function. Look at the other table. 2, 5, 6, and 6. 6 thought it was slip. 6 repeated. It's not a function. 6 thought it was slip. Too bad it wasn't. It's not a function. Any questions on ordered pairs or tables? Give a couple seconds for those who are still finishing up their writing. Before we keep it moving. And let us indeed keep it moving. So, 3A and 3B are both maps. So let's look at the rules for a map. Mapping diagram. It's a function if each number in the input points to only one number in the output. So in other words, an input number can't have two arrows going from it. So, for example, if you see that 4 is going to the number 3, that's okay. That's cool. If you see 4 trying to go to 1 and the number 3, that's bad. Why? You can't go to two different places at once. You cannot go to two places at once. You can't plug one number in and get two different answers. That's not mathematically possible. So let's look at 3A and 3B. So 3A. The easiest way to tell, look at each number in the domain and look at how many arrows does each number have. It can only have one arrow. So 4 goes to -1, one arrow. -2 goes to 4, one arrow. 0 goes to -1, one arrow. 2 goes to 1, one arrow. 4 to -4, one arrow. Each of them only had one arrow. So, this ends up being a function. All of the inputs pass. Remember, the y values can do whatever they want. It's the x values that have rules for it. The y values can do whatever they want. So here's one that fails. You have -3, -1, and 0. One of these numbers thinks they're slip. -3 is going to -2. -1 is going to -1. But 0 thinks it's slip. It's going to try to go to 4 and to 5. You can't go to two different places at once. So 0 going to 4 and to 5 is not valid. So this is not a function. Again, you can't go to two different places at once. Any questions on the map? Any questions looking at a map? you have it, make sure you ask it. If not, then last one is a graph before we actually do some computation. All right, so graph. With graphs, we do a little drawing. We draw what's called a vertical line test. So, vertical line. So, which way is vertical? Which way does vertical go? Up and down. Vertical is up and down. Horizontal is left to right. Horizontal is left to right. Vertical is up and down. So, you draw a vertical line through any part of the graph. It can only intersect the graph once. So whatever graph you have, if you draw a vertical line through it, it can only cut through that graph one time. Whatever curve is there, it can only cut through it once. So here's an example. Example, one that works and one that doesn't. So for 4A, there's this V-shaped graph that's already there. We're going to draw vertical lines. So you can draw a vertical line anywhere you want. Draw it anywhere you want. But it can only cut that graph one time. It only gets one time. So everywhere I drew it, it only sliced the graph once. That means it passed the vertical line test. It's a function. Pass vertical line test is a function. So let's do one that fails. We have a graph that's a circle. So again, this is an example. This is not all of the examples that exist. This is just one example of how it fails. Draw your vertical lines. So you should see the very first vertical line I drew failed. Cut it there, and cut it there. That's a violation. It failed the vertical line test. So it's not a function. Go ahead.
Okay, so in some graphs, if there's you have on all the graphs to find out if it's a function or not, you have to draw lines, or where there's some graphs where there's already lines, you can find out whether it's a function or not, depending on what the lines do.
Well, you always have to draw a vertical line. They're not going to draw the vertical lines for you. So what they'll give you is the graph to start out with. So an example of what you might see, you have the XY grid, and then you have a curve that's already there, another graph that's here. So this is what they would start you with. If I'm asking you, is that a function, you have to be the one that draws the vertical lines. Yes, you're based off of the curved line, not off of the y-x lines. So you're trying to tell, is the curved line the function, not the y-x lines? Excellent question. Any other questions on graphs? Showing whether a graph is a function. Don't be afraid to ask questions. The only dumb question is the one you don't ask. And that's only because you cost yourself the opportunity of getting an answer. So, notice a lot of what we've done hasn't had anything to do with adding, subtracting, multiplying, dividing, not really much in terms of computation. It's how to manipulate a drawing, a graph, a table. But functions are more than just manipulation. There's math that goes along with it. There's algebra that goes along with it. So let's do some of that. So far we've just been working with basic expressions, how to plug numbers in, how to combine like terms, distributive property, all that jazz. When we're working with a function, now we have symbols that we work with. The primary symbol is you have f parentheses x. So f parentheses x is not f times x. That's not what it means. This means f of x. So, since you're intelligent, I want you to be able to say it correctly. So f times x is not valid. F of x. F is the name of the function. X is the variable that you would see in the function. F is the name, x is the variable. So, you can name it however you want. So, for example, in the case of Naomi, Noah, and Nyla, I could name a function for all three of them. Their function is n of x. N is the name, x is the variable that you would see in it. I can name a function for Sam and Sinai. S of x. S is the name, x is the function. I can name one for Trent and Tyler. T of x. T is the name, x is the variable that's inside the function. So I can name it however I want. And these are three examples of functions. The left-hand side tells you the name. The right-hand side is the expression that you would work with. So, what can we do with something like that? We can evaluate a function. Just like we can plug numbers into an expression, you can plug numbers into a function. So if we're going to evaluate a function, plug the number that is inside the parentheses into the right-hand side of the function. And then work the problem out. Key thing, order of operations still applies. You still have to do order of operations. Parentheses, exponents, multiply, divide, add, subtract. Those still apply. Those still apply, they haven't gone anywhere. So let's do a few examples. So example 1, you have f of x equals 7x. So f of x is the name, 7x is the expression. They're saying find f of 2. This does not mean f times 2. This means take 2 and plug it in for x. Take 2 and plug it in for x. You only have to plug it in on the right-hand side. You don't have to worry about the left-hand side. Only have to plug it into the right-hand side. You only have to plug it into the right-hand side. But then you work it out. 7 times 2 is 14. Done. 7 times 2, 14, done. Let's do another example. G of x equals 1/2 times x minus 7 times g of -5. Same rule applies. Take -5 and plug it in for x. (1/2) times -5 minus 7. So, if I'm solving it out, where do I start? What gets worked out first? Parentheses. So, -5 minus 7 is what? Say that again. It's not 2. It's -12. Alright, I think that was you. You just have to speak up a little louder. So, -5 minus 7. Remember, you're subtracting, so that's keep, change, change. -5 plus -7, -12. Again, learning is always fluid. If you didn't pick up on it when it was first taught, that's fine. You still gotta learn it and pick up on it. Progress, not perfection. Half of -12. So what's half of -12? Part of the answer. -6. Positive times negative is negative. Half of 12 is 6. Questions on example 1 and 2? We're going to do example 3. We'll save the graphing part for tomorrow. Well, evaluating off of the graph for tomorrow. Alright, example 3. So you have h of x equals 8x squared minus 6x minus 1. H of 1/2. There's 2 x's. So that means you need to plug in 1/2 twice. 1/2 is going to get plugged in twice. Load this up a little bit so I can have some more space. So that's 8 times 1/2 squared minus 6 times 1/2 minus 1. So when you do order of operations, do you do exponents first or multiplication? Exponents. That means if you did 8 times 1/2, you're wrong. You can erase that, start that problem over. You do 1/2 squared first. One half squared is 1 squared over 2 squared, which is 1/4. You can, but you better know how to work with a fraction. If the problem says give your final answer as a fraction and you give it as a decimal, it's going to get marked wrong. So remember, fractions and decimals are part of our mathematical vocabulary, so we will always use them. So now we keep going. 8 times 1/4. Remember, 8 over 1 times 1 over 4. 8 over 4 is 2. 6 times 1/2. What's half of 6? 3. And if we solve the rest out, 2 minus 3 is -1. -1 minus 1 is -2. Questions on examples 1, 2, and 3. And it's not hard. It's not that you can't do it. You just got to put in a little work. It's not that you can't do it. You just got to put in a little work.